There's one ignition system that was used as a transition between distributor ignition systems and coil on plug. And you're looking at it right now. This is a Subaru Waste Spark ignition system. This right here is the ignition coil or coil pack. We oftentimes call them a coil pack because it's actually two coils in one. You see that if I draw this line here, this ignition coil feeds cylinder 3 and cylinder 4. This ignition coil on the Subaru feeds cylinders 1 and cylinder 2. Now that comes together in a pack or a part number, but what's unique about it is the way that it works, the way that Waste Spark ignition system functions. To understand that, you have to remember what companion cylinders are. So companion cylinders are the two cylinders that are at top dead center at the same time. All engines with even numbers of cylinders, so 4, 6, 8, 10 cylinder engines all have companion cylinders. And that means that two cylinders are going to be at top dead center at the same time. This is a standard 4-cylinder. This is not a Subaru. Subarus are a little different. But a standard 4-cylinder, the firing order is 1, 3, 4, 2. And if cylinder number 1 is this one and cylinder number 4 is that one, 1 and 4 are on top dead center together, and 2 and 3 are on top dead center together in another half revolution. But the thing to remember again is that even though number 1 is on top dead center, it's on top dead center compression. Number 4 is on top dead center exhaust. So which one of those is ready to have a spark occur? Number 1. Number 4 is not ready to have a spark occur. However, the way Waste Spark ignition system works is it will spark, or it'll provide a spark to both cylinders, and the number 4 cylinder, even though it's on the exhaust stroke, will receive a spark. Now the spark won't do anything, it'll jump the gap, but it won't do anything for that cylinder. And again, if we go back to our Subaru example for just a minute and we take a look, you can see how these cylinders here are paired and these cylinders here are paired. Now let's look at the next screen. This is kind of an example or a drawing of the inside. You remember, every ignition coil has two coils of wire in it. The primary side and then the secondary side. So this is the primary side, this is the secondary side. And remember, the primary side has a relatively short coil of wire, and the secondary side has a very, very long coil of wire. And you can see that in the way that this is drawn. So the primary side in this example, one wire on the primary side is fed with 12 volts all the time, and the other wire goes over to, in this case, the PCM. It could go to an ICM, but in this case it goes to a PCM where it's grounded and then ungrounded, and grounded and then ungrounded, to create a magnet inside of the primary winding. And that magnet, of course, affects the secondary. So now let's take a look at the secondary on this. So the secondary winding in here is where the high voltage is created, but what's odd is it's created out these two wires. So the way it actually works is you get a high voltage spike that will come down here, that will jump this gap, then the electrons will travel through this ground, through the cylinder head, up this spark plug, jump this gap backwards, and complete the circuit. Because remember, an electron won't leave unless it can return to the same circuit. In the case of an ignition system, the secondary coil of wire is the circuit. It's basically the battery. So current flow heads that way and comes back this way. It's a weird concept to think about. Let's take a look at this diagram. So this is maybe even a little simpler. This shows the primary winding up top, so we're not going to worry about the primary winding, we're just going to look at the secondary winding. The secondary winding, just like any battery or any electrical source, is going to have a positive and a negative. And we know that electrons are actually going to flow out the negative, and they're going to come around and flow back in the positive. But it doesn't really matter which way we think about this. We know that there's a positive and a negative, and the electrons are going to have to flow between them, and you won't have a complete circuit unless they can. So in this case, all the manufacturer did was they took these two companion cylinders, cylinders 3 and 6, and they attached one end of the coil to one spark plug and the other end of the coil to the other spark plug. And now this secondary winding creates enough voltage to jump a gap on the compression stroke, just like a traditional engine would. It'll come down and it'll jump that gap, and now the electrons go to ground. But because of the way they have the circuit hooked, the electrons will actually flow through the iron of the block, back up through the cylinder head, then into the threads of this spark plug, jump this spark plug backwards, and head back in to the other end of the secondary winding. It's kind of weird to think about, but it really doesn't matter that much that which way the electrons are flowing or any of that. But just be sure that you know that for sure, if it's a waste spark ignition system, every time the coil fires, the electrons head in one direction and return in the other, and one spark plug will get jumped forward, one spark plug will get jumped backwards. Again, it really doesn't matter as long as that there's an arc across the spark plug, it will ignite the air-fuel mixture. And then you say, well, now wait a minute. Okay, I get it. You want to ignite the air-fuel mixture, but over here, if this cylinder here, number 3, is on the exhaust stroke, there really isn't anything to ignite in there, and that's correct. It takes very little voltage to jump this gap. If this is the positive side and the electrons are flowing this way, it takes very little voltage to jump this gap backwards and send that back up. That's correct. But as the crankshaft rotates one revolution around, now cylinder 3 is on the compression stroke and cylinder 6 is on the exhaust stroke. So now cylinder 3 takes a lot of voltage to jump across because there's compression in the spark plug gap, and cylinder 6 is very easy to jump across. However, it doesn't matter which stroke each cylinder is on, the electrons are always going to flow the same way. They're always going to jump the spark plug the same way. And again, if we're looking at the gap of the spark plug, like zoomed way in on the spark plug, the electrons are either going to go this way or they can go this way. It doesn't matter as long as they bridge the gap, and when they bridge the gap, they ignite the air-fuel mixture. So the electrons are always traveling in the same direction. One cylinder, they jump backwards. One cylinder, they jump what we consider forwards. But they jump both cylinders. The one on the exhaust stroke doesn't do anything. It's what we call a wasted spark. And that's where that term comes from, waste spark ignition system. So why did they do this? Now, the reason they did it is because if you had a V8 back in the day, that ignition coil would have to fire all 8 cylinders. Every time the crankshaft went around, it would have to fire 4, and they would have to fire another 4. And that coil was working really hard. In this scenario, this coil only has to fire once for every revolution. So if I had an 8-cylinder engine, that coil is now only firing once every revolution instead of 4 times. So that means that the coil can run cooler and the coil has more time to build up for the next spark event. It's a much more efficient system. It also got rid of all of the moving parts of the distributor cap and rotor. However, it's not as efficient as a coil on plug, but you also only have half the number of coils. So again, if we look back at our Subaru example here, even though you're like, well, this only has 1 coil, no, it actually has 2 coils. There's a coil and there's a coil. They're all in one part number. However, when Subaru went to coil on plug, they had to go to 4 coils. In this example, there's only 2 coils. So this is more cost effective A coil-on plug is simpler and more straightforward, but this was a big step forward away from distributor caps and rotors. And these waste spark systems were used by some car manufacturers way into the 2000 model years, way into the 2000s. They were started in the 80s and were used heavily in the 80s and 90s, and still existed all the way up way into the 2000s. So you may run into one of these systems and have to know what's going on.